All right. So hopefully you're relatively familiar with the subsets of real numbers. Okay, real numbers are defined as the numbers that have a specific location on a number line. And they're broken up into several different categories that are common, again, that you should have reviewed over the last few years. The smallest category that we're going to be looking at here would be natural numbers. Okay, so the natural numbers are just the set of numbers that kind of exist in nature. So 1, 2, 3, 4. If it has if you can count those many blades of grass or those many trees, that's the natural number. So natural numbers would be a set like 1, 2, 3, and so on. Okay, so I'm going to kind of introduce these more visually. Okay, when you extend this slightly by one single number, we create the whole numbers. So whole numbers are all of the natural numbers plus 0. And so do you see how, by me drawing this box around, what that illustrates? So everything that is a natural number is also considered a whole number. And so whole numbers are just all of the natural numbers and with the addition of 0. Right? Now when you extend all of these and you mirror them across a number line or find their opposites, that includes the integers. So the integers would be all the numbers -3, -2, -1, 0, 1, 2, 3, so on. Okay, so again, as I write this, I'm just including the ones that aren't already included. Okay, so anything that is a natural number is also an integer. Anything that's a whole number, also an integer. And now if we extend this even further, we have what are called rational numbers. Okay, rational numbers are any number that can be expressed as a ratio of two integers. So here it's a fraction p over q, where p and q, and I'm just going to include them in this. So p over q are just integers. So if you have any numbers that are the ratio of two integers, that's considered a rational number. And so rational numbers include the following. I'm just going to write them down here a little ways. They include terminating decimals, and they include non-terminating, repeating decimals. Okay, so when we're looking at rational numbers, okay, we can include fractions here. So a fraction like 1/2 or -3/7. That would be an example of rational numbers. It's the ratio of two integers. We can take terminating decimals, so 0.31. If it has a specific end, it's considered a rational number. And then non-terminating but repeating decimals. So something like 0.33 continuing. And we can represent these either with a bar over the top, so that just means that the digits underneath the bar are repeating. Even though I put the bar over two digits, those digits are the same. So how many repeating digits are there in that number? Yeah, there's just the one, just the number 3 is repeating. Whereas this one, the ... illustrates that the pattern's continuing. And so 5, 2, 5, 2, so the next, it's just going to repeat that. And so how many digits are repeating in that number? 2, the 5, 2, 5, 2. Right? So that's your set of rational numbers. And if we take, again, anything that falls inside these boxes are still considered rational numbers. So all natural numbers and whole numbers, integers, are all considered rational numbers. Separate from this group is the set of irrational numbers. So notice I'm going to draw this in a separate box. Okay, none of these overlap. So irrational numbers are the set of numbers that can't be expressed as a ratio of two integers. Okay, and so rational numbers tend to be radicals that don't simplify into an integer value. There are several symbols that represent irrational numbers. Pi is the most common one. We'll also probably talk about the irrational number e that's represented by a symbol e. And then also included in this are the non-terminating, non-repeating decimals. Yeah.
How do we type that?
Oops, the square root of 2.
Yeah.
You can square root of 2. As far as, especially when we get to where you're entering these online, it'll be expressed SQRT parentheses 2. And then actually, since I included that too, the number pi, or the value pi, when you type that in, again, it's real specific, but it's pi and then open and close parentheses together. So whenever, and we'll talk about this as it comes up into items that you need to insert online, but pi is expressed pi with the open and close parentheses right after each other. A square root is whatever value is in the radical is going to be inside the parentheses after the SQRT. And thanks for asking that. Right, so in addition to these is the non-terminating, non-repeating decimal. So if I did something like this, 5.11212 dot dot dot. Okay, so the dot 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 means the pattern continues. So is there a pattern? Can you see a pattern in those digits? So it's 1, and then it's 1, 2, and then 1, 2, 3. So what do you think the next string of digits is? 1, 2, 3, 4, right? Okay, so you see there's a pattern, but is this pattern a set of repeating digits? No, it's a repeating pattern, but not the repeating digits. So this would be considered an irrational number. Right, it's only if the specific digits are repeating over and over again that it falls into the rational form. Right, so these all make up the whole set of real numbers. And so you are going to be asked on some questions to classify different numbers into a specific subset. And make sure that you can place them into these.